Hello coders, welcome back to Daily Coding. In this video we are going to discuss how to merge two sorted lists. Here we have given two linked lists that is in the sorted order and we have to get it in the sorted list and we have to merge together. So what should be the approach? If we merge this sorted list, suppose we have given two sorted lists and we have given this, we'll try to get this list in any other collections and we can sort it, and then we have to again build the linked list. In that way our problem will be solved. Either without adding, we just need to add it in the same linked list and we have to compare it, and then we have to build the linked list, then also our problem will be solved. Here what we'll do, I'll first start normal approach which is not more complex. We'll try to add this linked list in the priority queue. You know priority queue is priority queue is not a, we don't static is already sorted order. If you select the mean heap or maxim, based on that, if you select the mean heap, it is already sorted in the mean value will be in the top and then next value, so it is in the ascending order. And if you sort use the max heap, max value is on the top and our other value is after that, so it's a descending order. Here if you take the priority queue mean heap and we'll add this value, so then in that case our heap will be become like 1 1 2 3 4 4, and then we have to merge, we have to build the linked list. In that approach also our problem will be solved. So first we'll see using this approach and later I'll write code on the O of n complexity. This is n log n because every time if you insert in the mean heap, it's log n complexity, and if you are adding n value, it will be n log n. So let's write in this approach and then we'll try to solve in the other approach. So let's write it. First we have to priority queue integer mean heap new priority queue, and now we'll start iterating our linked list. So here we have to check while our list 1 is not empty. So we have to iterate till list 1 is not equal to null, and we'll start adding in the mean heap. Here we added in the mean heap and this value is list 1 dot val, and we have to move our list to next node. So here we can write it list 1 dot next, and same approach we have to apply for second list node also. while list 2 is not equal to null. In that case, we'll add this mean heap dot offer list 2 dot val, and we have to iterate list2 dot next, and now we have to build this new linked list which will keep this all value. So let's start first to create one list node dummy, which is a value list node -1. We just kept as a first node as a -1, and then we'll assign this list node dummy to current. So dummy is kind of engine, and we have to keep adding other node as a different bogey. So let me just start while our mean heap, we have to iterate till mean heap is not empty. So we have to iterate it till mean heap is not empty. And now we started filling our value. So here we are adding current dot next equal to current new list node, and we are putting the value of the mean heap dot poll, and we have to move it. So current equal to current dot next. We have to iterate all the heap value, and then all the heap value will be assigned in the current node, and in the end we have to return dummy dot next. So we created the dummy node, and in dummy node we have the -1 value, the first value. We don't want to return -1. In that case, we are returning the dummy dot next. Using this way, we'll get our result. Let's run this code and we'll see how it's working. Here we have lots of error. That is, let me correct it. So here is the spelling mistake. Priority queue. Still we have the error. So let's see. Here is also the spelling mistake. Mean heap is empty. And this is executed. Let me submit this code. So this is the past. If you want to solve this problem in more optimized way, how to do these things? For that, we don't have to put this value inside any mean heap. We just need to compare the first value. Suppose we started here and we are comparing with this value, list node 1, list node 2. If it is, which one will be smaller, that will add in the list, our new list node, and then we have to move to next. Then it will compare with the second value and the second value. And in that case, if it's which will in the right order, it will come here and we'll get that value. So we will get this value. Then we have to, our pointer will be here. So suppose we compare 1 1, this is the first pointer. We'll get this value, then we are move our pointer to second value. We moved our pointer here, and this is compared with 2 with 1, and 1 is the smaller, so it's came here. Then our pointer moved to here, and it's compared with 2 with 3, and then our value will become 2 here. It will come to here, and then our pointer move to this place, and it will compare with 4 to 3, and 3 will be here, and our pointer moved here, so it will compare with 4 and 4, and then accordingly. So what we have to do, we have to check if list1 dot value is less than equal to list2 dot value. In that case, we have to add list1 value in the current node, which will create the list node, and we have to move this list1 to list1 next. Same way, if this condition is false, in the else condition we have to write list 2 value here in the list node. We'll add the list 2 value, and we have to move our list 2 dot next. And maybe it is possible. So suppose, let me give the example here. Here is the example. In one value is available, in one value has the data, but another value is not the data. In that case, we have to write the edge case. If list1 equal to null, in that case we have to return list2, and vice versa. If list2 is null, then we have to return list1. Using this approach, we'll get this solution. And in other case, suppose we have in one node we have only 2 value, and another node we have the 3 value, then how we'll compare? So this logic will be only check both 2 nodes. If still list1 has the value available, if suppose if still list1 has the not empty, while list1 is not empty, not equal to null, in that case we have to again set the value list node list1 dot value, and move to we have to move to list1 dot next, and same apply for the list2 also. So in this approach, our problem will be solved in the O of n complexity. We have to only move one time, and our all the linked list will be solved. Linked list will be merged in the sorted order. So let's write this code, and we'll see how it will be work. So first we are creating the same approach. We are creating list node dummy equal to new list node minus 1. And now we are assigning this list node in the current. Now, first we'll write the edge case which I discussed here. If list 1 is null, then return list 2. If list 2 is null, return list 1. So we'll write the first edge case. If list 1 equal to null, we have to return list 2. Edge case 1 and edge case 2. If list 1, list 2 equal to null, in this case we have to return list 1. So that is the done. Now we have to write while list 1 not equal to null and list 2 not equal to null. So here we are checking if both is not equal to null, then only it will be executed. For that case only, if anything is remaining, we have to check separately this list 1 and list 2. So let me write the case for here. If list 1 dot val less than equal to list 2 dot val, in that case we have to assign current dot next equal to new list node, and here we are assigning the list 1 dot val, and we have to move list 1 dot next. In the else condition, if list 1 is not list 1 has not less than equal to list 2, in the else condition we have to check and write current dot next equal to new list node, and here we are writing list 2 dot val, and we are moving list 2 to list 2 dot next. And we also need to be move our current. Here we write current dot next. We are moving our current value. Now we have to check the edge case if while only list 1 not equal to null. In that case, we need to again add in the current dot next new list node, and here we have to write list 1 dot val, and we have to move list 1 dot val list 1 equal to list 1 dot next. In the second condition, and in the second condition we have to write while list 2 not equal to null, and we have to move the current value here also. Current equal to current dot next, and current dot next will assign the new list node value, list 2 dot val, and current equal to current dot next, and list 2 equal to list 2 dot next. And in the end, here we are return dummy dot next, because in the dummy we also have the -1 value and we don't need that value, so we have to return dummy dot next. And let's run this code. Here this is all the test cases passed, and let me submit this code, and this is also passed. So we see two approach for this Java code. One is using a another collections. Here I used main heap. So we are storing all the value inside the main heap, and then we are building again the linked list. In the second approach, I was just comparing in the only one loop, and we are building the linked list there only. And complexity will be, in the first approach we have the complexity of n log n, and in the second approach our complexity will be of n, and the space complexity will be also in the first approach. It's O of n, because we are adding additional main heap, but here it is a constant is space complexity will be. So I hope it's very clear and how to write this type of question. If you have to ask, you can try to solve it in the both approach. So thanks for watching, and please, if you are start liking the video, please like and subscribe. Thank you all for watching. We'll meet in the next video.